Today class will discuss the electric drive and block diagram of electric drive. Drive is nothing but aggregation and combination of prime mover, energy transmitting media and load where energy utilized, that place we can use the drive. Mainly drives are classified into two types, electrical drives and mechanical drives. Here electric drives is nothing but electrical energy is converted into mechanical energy, and mechanical drive is nothing but mechanical energy is converted into electrical energy. This is the main block diagram of electric drives. Here we are using the source, prime, power modulators, motor, load and sensing unit and control unit. Here first I will discuss the sources. Here we know that fundamental electric sources mainly classified to DC supply and AC supply. Here we know that DC supply is nothing but 230 voltage DC. Single phase supply further classified to two types, single phase supply and three phase supply. In single phase supply we have used the 230 volt 50 Hz. Next three phase supply normally we have used the 440 volt 50 Hz. This is the sources are mainly classified in the electric drives. The fundamentally you know very well, my dear students. Next, power modulators. Power modulators is nothing but here conversion of power. Normally we have used the converter, inverter, chopper, AC voltage regulator, cycloconverter. Here we know converter is nothing but convert the fixed AC is converted into pulsated DC. Next, inverter is nothing but fixed DC is converted into variable AC. Chopper is nothing but we are using the fixed DC is converted into variable DC. Next, AC voltage controller is nothing but we are using the fixed AC voltage is converted into variable AC. Next, we are using the cycloconverter. Cycloconverter is nothing but fixed frequency is converted into variable frequency. Here depends upon user application. We can prefer the power modulators. We are using the mostly we are use the converter, inverter, chopper, AC voltage control. Using the DC motor and AC motors. Here we know DC motors mainly classified to separately, mainly classified to DC motors and AC motors. Here we know DC motors excitation wise we have classified to two types, separately excited DC motor, self-excited DC motors. Here we know what are the main parts of electric motor is nothing but armature and field winding. Here separately excited, for that separately excited motor both armature and field winding is called as separately excited DC motor. There is no classification in separately excited DC motor, but self-excited DC motor mainly classified to three types: shunt, series, compound. Here shunt is nothing but armature winding across you have connected the field winding. Series field winding, seriously armature winding is connected to the field winding. Compound motor further classified to two types, long shunt and short shunt. This is the main classification of DC motors. Here AC motors mainly classified to synchronous motors and asynchronous motors. Here we know synchronous motor is nothing but we are using the 1500 or depends upon Ns equal to 120 F dot by P. Now rotate the synchronous speed. Depends upon frequency and number of poles. Here constant speed motor also called as synchronous speed motor. We are using the frequency and number of poles depends upon your motor speed constantly run the system. It's called as constant speed motor or synchronous motor. Asynchronous motor mainly classified to two types. Induction motor mainly are used, single phase induction motor and three phase induction motor. Here depends upon our electric drive requirement, we can prefer AC motor as well as DC motor. Also we have considered the special motors also. Normally we are using the switch reluctance motor and BLDC motor. Mostly I use the drives application. This is the main motor usage in the DC motors and AC motors, and special electrical motors we are using the SRM and BLDC motors. Next we are using the sensing unit. Here normally we are using the sensing unit. Normally I use the speed controller and current controller. Here we know speed controller we are using the tachometer and current controller mostly we are using the Hall effect sensor. The control unit control the circuit. Here mainly control the firing angle only. Here we know firing angle is inversely proportional to average output voltage. Depends upon our requirement.